Good morning, children. Hopefully I'm back with you. Good morning, Demi. Hey, I'm here. That's made me go, oh, I'm very, very flustered. I'm glad I've got my wingman, or woman, Miss Francois by the side of me, and Mr. Coxon on the end of the phone. So that was a bit scary for a moment. So anyway, I will go over our teaser in a moment. So welcome to Maths, Lesson 8. Can't believe it's 4 weeks that we've actually been doing these lessons. And today we are going to be reading and interpreting information from tables. So I don't know how this lesson's going to go, to be perfectly honest. And because we're not in a classroom together, it makes it quite difficult to see how a lesson's going to go and what we do. So I've tried to keep it as maybe as simple as I can for us, because we've got to bring a lot of skills into this lesson. So outcomes: to know and understand intervals of time, because to read tables, including timetables, you have to be able to calculate changes and units and intervals of time. We need to identify and calculate steps of time. So we need to be able to add time. We need to be able to find differences in time. We also have to be able to work out how a timetable works in terms of how the trains or the buses or whatever it is we're looking at, how they actually travel, because sometimes some journeys take longer than others because they go a different route along the way. So we need to be able to do that and to be able to read tables and interpret information on them. That's what our main outcome is today. So good morning, Dave, Alex. Good morning. So we've gone over our maths teaser with our technical glitch. So it was: a farmer has 19 sheep on his land. One day a big storm hits. There is thunder, lightning and hailstones, which frightens the sheep, and all but 7 of the sheep run away. How many sheep does the farmer have left? Some of you got this quite straight away, which was good. But I was really, really pleased, because at home I try these out on my partner, and invariably he gets them straight away, and this one he didn't. So it kind of gave me hope, because maybe it was just, but I don't think he was listening properly to me. That's the thing I think that happened, really. So the farmer has 19 sheep on his land. So the storm hits, all but 7 of the sheep run away. So how many does he have left? And the answer is 7, because all of the others run away, which is 12 of them run away, but 7 stay. So all but 7 run away, and that's where the clue is. So good morning, Rihanna. So that is how it works out 7, and the clue, and it's a bit like word problems, really. When we looked at word problems previously, sometimes we get caught up in the words and we don't really think about the maths in there. So well done to all of you that got that right first time, and I think that's a win over to you and not to me, because so many of you got it. But I'm glad that I managed to make some of you think with that one. So our previous learning: what you are going to need to know in order to access and understand today's learning. And to be honest, it is quite a lot. So how to read the time, analog and digital time. We need to know how to read the time in order to read timetables. Time is a key word in that, and we have to be able to read the time. We have to know how many minutes are in an hour, half an hour, quarter of an hour, and so on. We need to understand divisions in time. So are we counting steps of 5, 15, 30? What a timetable is and the purpose of one. Why do we have them? Why do we need them? What service and what purpose do they have for us? and what calculation you need to use to find a difference. So a difference is very, very important. And I'm going to give you a definition of it now, so you need to be listening carefully because this might come up later. So a definition is when you have a quantity of an amount that you need to subtract from another. So when you find the difference, you are subtracting one amount from another. So you might need that piece of information later. Well, you'll definitely need it later. So I think I've stopped shaking from the technical glitch now. So what we have previously learned. So where has our learning journey in school taken us so that we can get to this point? So we've learned how to tell the time. We've learned to convert between different units of time. So that's analog time when we say o'clock, to digital time when we use a 12 or 24-hour clock. And we've also learned how to interpret data from a table. And we can go all the way back to year one to interpret data from a table, a simple table as a pictogram or a tally chart, like the one that Miss Francois uses to tally your scores. And you can interpret data from that table. Okay, so time. So we can tell the time, hopefully. We know that, oh, and I don't think I got my pointer ready. We know that if the hour and is pointing towards the 12, it is an o'clock time. If it moves to the 1, it is 5 past. Our divisions in time are steps of 1 minute, and then we combine them to make 5 minutes. So we've got o'clock, 5 past because it's 5 minutes past, 10 past when we get to 2 because 10 minutes have passed since the o'clock time. Then quarter past, we say quarter past, we don't say 15 minutes past, we say quarter past. And then we count to 4, which is 20 past. Then when we get to 5, we say 25 past because it's 25 minutes past the o'clock time. And then when we get to the 6, we've made it completely halfway around the clock and we're at half past. So we've made it halfway. So we don't use the word past anymore. We use the word to. So here we say half past, which is 30 minutes past the o'clock time. But now we start to count how many minutes to. So from the 7 to the next o'clock time, it's 25 to. From the 8 to the o'clock time, if we count 5, 10, 15, 20, it's 20 minutes to the next o'clock time. And then quarter to, again, we say quarter instead of 15 to, because we are now quarter to the o'clock time. We've got a quarter of a way left to go to that o'clock time. When we get to the 10, that's a nice easy one because it's 10 to, 10 minutes to the o'clock time. And 5 to the 11 means we've got 5 minutes to go until we reach that o'clock time. So that's a whistle-stop tour of our learning time, and we call this analog time. So the digital clock. Now, digital clock, we can have a 12-hour digital clock or a 24-hour digital clock. When we have a 12-hour digital clock, when we get to 12, we start again at 1. When it's a 24-hour clock, we go from 0 at midnight all the way round 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 to 12. And then when we get to 12, our afternoon starts 13, 14, 15, 16, 17, 18 into the evening, 19, 20, 21, 22, 23, 24. So that's why it's called a 24-hour clock, because it goes up to 24. So when it's an o'clock time on a digital clock, you will have 2 zeros after the point. When it is 5 past, you have a 0 and a 5. When it is 10 past, you have 1 and 0. It says 10. Quarter past, 15. 20 past, 20. 25 past, 25. They're the easy ones. So then we get to half past, which is 30, because that's 30 minutes. And so that's how we link it to the analog time. Now, when we get to 25 to, we start to say 35. And that's because we're counting in digital time, we count away from the o'clock time. So we're now 35 minutes past the o'clock time. When we're at 22, we're at 40 minutes past the o'clock time. When we're at quarter to, we are 45 minutes past the o'clock time. And so on. 10 to is 50 minutes and 5 to is 55 minutes. And then we start again. And as it's 13:55, the next time on this clock would be 1400 hours. 14:00. A lot to remember, isn't it? I told you there was such a lot that we need to link to what we've previously learned in this lesson. So we also need to know about the relationships between seconds and minutes, minutes and hours, not so much days, weeks, or timetables, although some timetables, Sundays, weekends are different, so you might need to know how many days you have of that timetable. So the most important information we're going to need today is 60 seconds in 1 minute. So 60 seconds in a minute and 60 minutes in 1 hour and 24 hours in a day. We should know that there are 7 days in a week. Sometimes this one catches you out, 365 days a year, 52 weeks in a year. And we looked at this when we did 10, 100 and 1,000 work. So 10 years is a decade, 100 years is a century, and 1,000 years is a millennium. So here's where we need to focus our learning on our seconds and our minutes and hours relationship. Good morning, Libby and Isla. So, what is a table? Who can tell me? Can you answer me that question? Can any of you, because I've been talking for quite a while now, can you tell me what a table is? A mathematical table, not a literal table that I'm sitting in front of now, or that we use to eat our meals off. But what is a table? Over to you. Anybody feel daring enough to have a go for us? Oh, Amy, it is a grid. Well done. Thank you for giving me an answer there. Is anyone else going to join Amy in being brave enough, showing your Lee Forest values, finding you're brave and pushing your limits? Oh, I like that you've linked it to your bar model, Jay, but tables and bar models are different, but we'll look at tables, and a bar is like a bar that we break up to show a calculation. Columns and rows, something something you can put tally marks in. I like it, Zach. Okay, so what is a table? A table is a way of representing data, information that we want to read and we want to link together. Okay, so what is a timetable? What is a timetable? So a table is a way of showing us data. What is a timetable? What does a timetable do? You should be used to timetables. You get a new one every day. What is the purpose of them? Well done, John Paul. So a table is a grid for storing data. That is correct. So what is a timetable? What does a time? How does a timetable help us? What's its purpose in our lives? Those times of information. Thank you, Summer. It shows you when something needs to happen or completed by. It does tell you times to do your work. It tells you what to do. Yeah, a timetable that helps give us structure and timings because we only want certain timings for a day. So at school we only have so many hours a day, and we have a timetable so our day is structured and ordered so that we know that at this time this is what we're doing, but we only have that amount of time to do it in. So it's a way of structuring and ordering and letting us know how long we've got to do something, how long till the next thing comes along. So I know, like, when we're at school and we're on a Tuesday, you all want to know when swimming is coming along or when PE is coming along. So it helps us. So what are they used for? They are used for helping us to structure information, to follow a timetable, to give ourselves timing, so the structure to things. And also, if we are using a timetable for trains or planes or buses or our favourite TV programmes, they tell us what what bus or train goes from where we want to go at what time the next bus is, how long it takes us to get to where we're going, whether it stops at a certain station or a certain bus stop, because they don't all stop. So they give, in that context, they give us lots of information so that we can plan our journey, which is important and will be important if we ever all get to go on a journey ever again. Okay, so let's look at a table. So we're going to look at a table, and this table is about population. Excuse me, my my voice is going a bit crackly there. So in this table, we've got data that tells us about a city and the population, and the population is how many people live somewhere. So in the city of Leeds, 720,000 people live. In the city of Wakefield, 316,000 people live. In the city of Bradford, 467,000 people live. In Liverpool, the population is 440,000. And in Coventry, 305,000 people live there. So obviously those numbers fluctuate because most cities have visitors, so the population, but it's the static population that this is counting. So we can ask simple questions to begin with. So we can ask a very, very simple question about that table. And usually when we start work in school and in your SATs, good morning, Solomon. In your music, start your SATs. If you get questions like this, which undoubtedly you will get ones that kind of warm you up to understanding tables. So we can ask simple questions. Okay. So which city has the highest population? Okay, so who can tell me, over to you, which city on my table has the highest population? Well done, Amy. Well done, Summer. Well done, Lexi. Well done, Jay. Well done, Maisie. Okay, so I'll give you another 30 seconds. Well done, John Paul. I've only got correct answers at the moment, so that's a really good sign. So well done. So the city with the highest population is Leeds. So many of you were correct there, so well done. And Leeds has a population of 720,000 people. So that's a nice, simple question. Well done, Zach, to begin with. Oh, Jude, thank you. Alex, well done. Still using the same table. Then the questions can become more challenging. Okay, so what is the difference between the highest and the lowest population? Don't worry, I don't want you to do this just yet. We're listening at the moment. So what is the difference between the highest and the lowest population? Okay, so the highest, I know, is Leeds. And the one thing about the table is it isn't in order, in a specific order. So I'm going to have to look through and see. So the city with the lowest population is Coventry. Okay, so I know they are my two cities. Okay? So this requires a calculation. I can't remember what a difference means. Can you help me? Now, at the beginning, I explained what a difference was. So who can help me now? I can't remember. So I can't answer the question without knowing what a difference is. So who can help me and explain what a difference is? Did give you a clue and tell you that you needed to listen and that it would be. Oh, this is taking some thinking time. Who's going to be the first one to push their limits and be brave? Oh, but what is the difference between things? What is it mathematically? Because difference mathematically can mean something different to the difference between rain and sun. Difference mathematically as a specific meaning. But thank you, Amy, for being unusually brave there and pushing your limits. Am I going to have to help you out? Let's see, 30 more seconds, I think. Come on, who can be unusually brave and push their limits? Show the Lee Forest spirit. Oh, dude, I don't want the answer. I wanted to know what a difference was. Okay, so I'll help you out. Difference. Finding a difference involves subtracting a smaller quantity from a larger quantity. Okay, for example, the difference between 5 and 7 means 7 subtract 5. So that's what difference means mathematically. It means subtracting a smaller quantity from a larger quantity. So you need to know that. Okay, so now the calculation. So my calculation is 720,000 subtract 305. And that's because 720,000 was my highest population and 305 was my lowest population. But my lines have appeared at different times. So 0 take away 0 is 0. 0 take away 0 is 0. 0 take away 0 is 0. Okay, so now I've got 0 take away 5. Now if I've got 0, I can't physically take away 5 if I'm working with positive numbers. So I'm going to have to exchange a value. So I'm going to go to the 2 and I am going to exchange its value. And so that will become 1 and my 0 becomes 1. So now I can say 10 take away 5. I know it's 1,000 take 10,000 take away 5,000. But I keep saying this, when we work mathematically, we always talk in units because it makes maths so much easier for us to understand. So 10 take away 5 is 5. 1 take away 0 is 1. And 7 take away 3 is 4. So the difference is 415,000. So there's 415,000 more people living in Leeds than there are in Coventry. Well done for the correct answer, Maisie, but you jumped ahead. It's your turn now. So now it's your turn. Using the same table, what is the difference in the population between Wakefield and Bradford? So what is the difference in the population between Wakefield and Bradford? Over to you. Well done, Amy. Closely. You were a millisecond behind with the correct answer there. Well done. I'm so impressed with your maths skills. Your English skills are amazing as well. Summer, well done. Isla, well done. Danielle, Lexi, well done. John Paul, excellent, well done. Maisie, this is looking great so far. Give you another 30 seconds. Zach, well done. I just have to say that I don't mind what order you come in on the screen, so long as your maths is accurate and all of the answers have been correct. So that is amazing. I'm really, really impressed. And whether you got your answer first or last doesn't make any difference so long as you've got the correct answer. Impressive. So the calculation that you should have carried out, 467,000 subtract 360. So the first three are nice and easy again, 0, 0, 0. 7 subtract 6 is 1, 6 subtract 1 is 5, and 4 subtract 3 is 1. So the difference is 151,000 people. That's nice and easy. So we can clearly see how we can find differences when we use tables but we're stepping it up now. So timetables can be a bit more challenging to understand because they tell us a lot of information and we have to identify the information that we need. So if, I don't know if you ever stood in the train station and or at the bus stop and tried to work out the timings of the bus you want to catch when there's got the bus that it runs that day, what times it runs in the evenings, what times it runs at weekends, and then the next bus, and bank holidays, and there's lots of information on there. So they can be quite confusing. So we've got a timetable that I've kept quite simple to read, really. We've only got 3 journeys. We could possibly have more, but because we're virtual learning, I'm going to keep it to 3 journeys, okay? So on a journey timetable, there are different pieces of information to work through. So we've got where, because you might be in Derby and want to get to Newcastle. You might be in Sheffield and want to get to London. You might be in London and want to get to York. Just depends where your journey is taking you, okay? And the time of each train. There are some blanks, and the blanks actually mean that at that time, if you want to get to Derby, you cannot catch the 11:30 train because it doesn't stop at Derby. And journey C, if you want to get to Newcastle, the 1640, sorry, doesn't stop at Newcastle. Okay, so there's lots of things that you have to work through and understand what you want from a timetable. So different questions. Questions like, where will my journey start? Okay, so where will my journey start? Where is my final destination? Where is the place that I eventually want to reach? How long will it take to get there? Are some routes quicker than others? Does some journey take longer? So is it better that I catch the earlier train or bus and get there maybe an hour earlier because it might be too late otherwise? And what time do I need to get there? So what's the time I need to be at that place? So if I was going for a job interview and I wanted to be in York for, I don't know, 3 o'clock, I would have to take the 11:30 train, and I would be in York a lot earlier than I wanted to be, but that's the only option that I have. So we have to think these things through. So journey B takes 1 hour to get from London to Derby. What time do you arrive at Derby? I'm leaving you to do that question on your own because that's quite simple. Journey B takes 1 hour to get from London here to Derby here. So what time will I arrive in Derby? Over to you. Well done, Amy. What time do I arrive? There isn't a time here on my timetable, and it takes me an hour to get from here to here. So what time do I arrive? What is the time? Well done, Maisie. I know what you mean, Demi, but you forgot the zero, probably in your haste to type very, very quickly. But I think you know what you mean. Lexi, the question says 1 hour to get. It takes 1 hour to get from here to here. So what will that time be? Well done, John Paul. I think you've done the same as Demi in your haste to type. You've left the zero off your time, but I know what you mean. Wasim, think about what changes if it's 1 hour more. Thank you, Alex. Well done. Toby. Almost there, Lexi. But if you're counting on 1 hour from here, what is the time? Quite a few of you are missing out your zeros in the time. That's it. Well done. Well done, Lexi. Well done, Summer. Chloe B. Okay, so it's 12:30. An hour later than 11:30 is 12:30. And I put PM, but I should have perhaps left it at digital time. So that was not should have been a nice, easy question about the table. So how long does journey A take? Okay, so how long does journey A take? So how long does it take to get from London to Newcastle? And I've given you a clue. You will need to add up the minutes these journeys take. So the minutes from here to here, the minutes from here to here, the minutes from here to here. That's quite a tricky question because there's a lot of addition to do there. So I'm going to give you a little while to do that. So how long does journey A take to get from London to Newcastle? So how many minutes to get from here to here? How many minutes to get from here to here? How many minutes to get from here to here? And how many minutes to get from here to here? And then total them up. Good morning, Harley. You've been quiet this morning. Nice to have you with us. Oh gosh, Amy, that popped up so quickly. I've actually missed it. So well, I don't know. Your mathematical brain amazes me. Let's see if you totaled up all of the minutes because we've got 10:15 to 12:15. We have to calculate that. So we've got to add up those minutes. Then we've got to add up 12:15 to 12:40. Then we have to add up 12:40 to 13:20. And then we have to total the minutes to get from York to Newcastle, 13:20 to 14:05. There are a lot of calculations there. And I have to be honest, it took me 2 attempts to get it right. So we're thinking about what we need to understand as well as getting our calculation right. So what is the question asking us? Oh, close, John Paul. Your hours are correct. I'm not sure whether you might have Mr. Zero again. Well done. I'm so impressed with your maths as well. You're going to be a shining light in the classroom when we come back. I think I'll be able to give you and Amy Lee the job of, sorry, not Amy Lee, Amy Eggington, you the job of teaching the class, closely followed by Maisie. I'll be able to sit with my feet up. And in case you didn't know, Maisie, that did mean that you had got the answer correct. So well done. I know this is hard. That's why I'm giving you an extra time, a bit of extra time, and I don't want you to feel rushed. And I have to say that helps me a lot because I feel I've come on leaps and bounds because before, when I first started doing this live learning, it seemed like forever. Just sitting, giving you a minute to do something seemed like forever sitting here. But now I can be relaxed. Wasim, superstar, well done. But I will only give you possibly another minute, see if we can get some more correct answers up there. Is this the first time I've seen your name pop up this morning, Wasim? Sorry, good morning. Oh, Amy has actually now given me the calculations that I need to go through. So let's go through this together. The answer was 3 hours and 50 minutes. And it takes 2 hours or 120 minutes to get from London to Derby. It takes 25 minutes to get from Derby to Sheffield. It takes 40 minutes to get from Sheffield to York. And 45 minutes to get from York to Newcastle. So our total time to make that journey is 3 hours and 50 minutes. So, another question. You arrive at Sheffield train station at 18:10. How long do you have to wait for the next train to Newcastle? Okay, so you arrive at Sheffield, you arrive here, and you want to get to here. How long do you have to wait for the next train to Newcastle? Not what time it is, how long do you have to wait? You'll need to calculate the difference. Or you could count on if you wanted to, but I would calculate the difference. Thank you, Amy. First in with the correct answer. Summer, well done. Wasim, think about the question. I arrive at Sheffield at 18:10 and I want to get to Newcastle. If I'm at Sheffield and I want to get to Newcastle, so I'm at 18:10, it only gives me one choice because I've missed all of these. So it only gives me one choice. So how long do I have to wait? Well done, Maisie. Let's see maths today, guys. Well, this might be quite tricky, but some of you have shown me that I haven't made it tricky enough, I don't think. Okay, so let's have a look. It's 20 minutes because I've arrived at Sheffield at 18:10. The next train leaving is 18:30. So what is the difference between 18:10 and 18:30? So I could calculate a difference, or mentally, if I'm very good at telling the time, I could say 18:10, which is 10 past 6. So 10, 20, 30. So it's 20 minutes. So there's a 20 minutes wait in between. So how many stations does the 11:30 train stop at before it reaches York? So how many stations does the 11:30 train stop at before it reaches York? So if I catch the 11:30 train, how many stations does it stop at? Think carefully about what a blank space means. So can anyone beat Amy? Oh, think about it. This is one of like the teaser questions. So how many trains does it stop at before it reaches York? You have to include York itself. Yeah, I've counted a stop at Derby, I think. It was very hard to do this lesson yesterday. I've got an answer of 2 because I counted Derby. So well done to all of you. Okay, so that was quite a simple way of reading tables. There are lots and lots more trickier questions you could have around tables, but I wanted to make sure that we had a clear understanding of tables. So to do pupil voice for next Tuesday, I need to plan your lesson for next Tuesday. And believe it or not, Miss Francois and myself take a long time to plan these lessons. It's amazing how long it takes and to make all the slides so that we can make it accessible to you. So I need a bit of time to put together your lesson for next week. And it's your pupil voice. So this is what we've covered. We've covered multiplying 4 digits by a 1 or 2 digit number. We've multiplied by 10, 100 and 1,000. And it's not on there, but we've also divided by 10, 100 and 1,000. We've solved problems involving multiplication and division. We've done rounding. We've looked at percentages and reading tables. So out of that, is there anything you would like me to revisit again? Is there anything that you've done with Miss Jesson that you think, oh, I didn't quite get that? Could we go over that again? Can you comment now and let me know, please? Thank you, Lexi. I am writing that down as they come through. I am writing them down so I know what to do. I like teaching that one as well, so that'll be nice to go back over. And there's some other things I need to teach you along with there. Anyone else? I know John Paul told me something that he'd like to go over again last lesson. So, okay. Thank you, John Paul. Is that multiplying or dividing though? Or both? Okay, so if there's anything else, you can always message me on Classroom, in Classroom, or you can send me a dojo message. So let me know what we'd like to go over. You might want to go back and look at the table of what you've learned with Miss Jesson and see if there's anything that you want to come up. Thank you, Amy. If you want to cover that way as well, because you've done so much with her that I actually can't remember. And so to do lunch, for once, I have taken up your whole hour. So lunch, make sure you have a rest. Don't know about you, but my maths brain is aching just a little bit. And then complete the doodle activities for English and math this afternoon. Then you've got a really nice topic lesson to do, learning about Henry VIII. So have a lovely afternoon, and I'll see you next Tuesday. Bye.